The Tacoma Narrows Bridge was roughly 6,000 feet long and was located in Washington, which went over the Tacoma Narrow Strait of Puget Sound. The bridge's original design, which included the use of trusses, was rejected due to its high cost. Instead, it was decided that they would use narrow plate girders, which are lighter and more cost-efficient to create a suspension bridge. This newer and cheaper design needed to take into account not only gravity but also wind, as the bridge was much lighter. In 1889, Northern Pacific Railway proposed for a trestle, which is where the desire for the bridge began. Solid attempts for the bridge began in the mid-1920s, which included campaigning, funding, and consultation of bridge engineers. A proposal was made in 1929 but was ultimately cancelled in 1931 due to a lack of funding. By 1938, funds for the bridge were received and construction began, which only took 19 months. During this time, swaying of the bridge was noticed, which earned it the nickname Gallopin' Gertie. The bridge was opened on July 1st, 1940 and collapsed only 4 months after on November 7th. The effect of wind, even in small amounts, would lead to large oscillations in the bridge, but this is not what caused it to collapse. The collapse was due to the aerodynamics of the bridge and how it interacted with the wind. Small twists in the bridge were amplified, which caused the famous vertical waving motion to occur. This phenomenon is called aerostatic flutter. Too much flutter resulted in lots of stress on the bridge, causing it to collapse.
When considering the circumstances leading to the failure of the Tacoma Narrows Bridge, there are a variety of contributing factors which could have mitigated the risk of disaster. The bridge was a cutting-edge suspension bridge design, but throughout the advancements being made, there were inadequate efforts to evaluate the new design using models and wind testing. Further, there are failures of the engineers managing the construction to report the danger of the bridge. In regards to the Professional Engineers Act in Ontario, there are two key sections. Sections 72 and 77 outline professional misconduct and the Code of Ethics respectively. There were violations of Section 72.2.a negligence through the lack of testing, and Section 72.2.c failure to act to correct or report a situation that the practitioner believes may endanger the safety or the welfare of the public through not blowing the whistle of the dangers of the bridge. Where Section 72 is violated, there are issues of Section 77.1.1 fidelity to public needs and Section 77.2.1 regarding the practitioner's duty to public welfare as paramount being violated. In summary, there were grave violations of both the statutes of professional misconduct and the Code of Ethics. Alternatives that may have avoided the situation could include testing the design using a scale model and furthering testing using engineering tools such as a wind tunnel. And finally, engineers who were able to witness the danger to the bridge during and after construction should have reported it in the interest of public safety.
We will analyze and test each alternative should be tested to see if it is ethical or not, with relation to the Professional Code of Ethics and Ethical Principles, Section 77.2. The main problem of the bridge was its great flexibility in combination with turbulent winds. Bridge engineers in the 1930s considered failures in suspension bridges to be a result of unsustainable traffic loads and shoddy construction. The effect of wind was never considered. It became apparent to engineers how significant proper research, testing, and modeling was to deliver architecture that could withstand the elements. Specifically, wind tunnel modeling would have proven how unstable the design was before construction had even commenced. The importance of aerodynamics in bridge construction became clear, showing that all research methods should be used. This aligns with the Professional Code of Ethics, Section 77 of Reg 941. Engineers must uphold integrity and strive for greater excellence. The second alternative, according to the PEO's Code of Professional Conduct, gives the inability to report a circumstance that an engineer believes may endanger the well-being of the general public. It would establish professional misconduct on the part of the engineer. Although this would not have stopped the construction of the bridge with inadequate knowledge, it would have ensured proper precautions to have been taken to prevent endangering the public. Although the redesign and reconstruction would have been costly, the total cost of having to rebuild the bridge was substantially greater. Once the bridge has been constructed, there were multiple unsuccessful attempts to resist the effects of the wind. Instead of approaching the problem piecemeal, a complete redesign and reconstruction would have been safer when instability was detected. This aligns with the Code of Ethics, as it is an engineer's duty to report. Alternative 1 is chosen as it shows how to follow the Code of Ethics and the devotion to high ideals of professional integrity, knowledge of development, and competence. By undergoing proper and effective research, the collapse and bridge could have been prevented.
The Tacoma Narrows Bridge incident is a case of tort law where the defendants are the U.S. moneylenders and the Public Works Administration, and the plaintiffs are the residents of Tacoma and Peninsula. The U.S. moneylenders and the Public Works Administration that funded the bridge must ensure the safety of the public as it is their duty to design and construct the bridge for safe public use. When the bridge was open, the ferry that transports commuters across was closed, but when the incident happened, residents of Tacoma and Peninsula has no means to cross over the other side. This left damages that must be compensated as commuters that relies heavily to the bridge can't go to work. Also, merchants on both sides of the bridge lost income from the retail trades between Pierce and Kitsap counties. For many Peninsula residents, the Narrows Bridge had been a lifeline connecting the rural area to the commercial centers in Tacoma and even Seattle. It took a while for the ferry services to come back to accommodate the residents. The engineers and defendants caused damages and now owes the plaintiff a duty of care.
The project engineer was forced to follow the furnished designs by the defendant. One of the Public Works Administration engineer, David Glenn, refused to approve the design of the bridge when it was built. A report was submitted containing the warnings of faults in the design and refusing to recommend acceptance of the structure. The defendant endangered the residents by their conduct of refusing to follow the suggestions of their engineers. This caused damages to the businesses and the residents of the affected area. The defendant denies the allegation, refusing their duty of care to the plaintiffs.